also call before I go to your house.
Yeah, okay.
Or you could call me or something.
You have a phone?
Yeah,
Because I don't have your...
Yeah, I can give you.
Okay.
Well, I'll give you my mom's number.
Okay.
Cheers. It's so cold. I know I'm wearing like 2 jackets.
Always.
What? Ooh, I like your top. That's really cool with the design.
Oh my god, I thought that was a bug for a second, but it wasn't. The bug.
It's like the tiniest bug. Gosh. You're like
Freaked out over
billions times the
Infinity is bigger than it.
that's what always gets me. I'm just like, thanks, but they can
Just sit right in front of
That's
me.
true. Like, okay, you wanna like watch out for bees. Like, especially like venomous ones. But like, you
Well,
want
they're the wrong job.
Yeah, like,
Like, bite you.
but like little bugs. Why are you in that? But it's
They're
just
just
like,
creepy.
I know.
You could
That's
probably
true.
Like
extend the legs.
cockroaches.
It's like Lauren's head is creepy.
Yeah.
Do you want the camera at the TV for physics?
I was just
Yeah.
like,
Do you guys want to go over more questions on your own?
I have 2 questions.
Yes.
Yeah.
Okay. And then if we have time, well,
I'm so proud of myself. Not all done.
very good. I do want
I
to see
stayed up
it.
until like 1 o'clock.
Did you wait till the last?
No, I didn't. I got home at like 9 o'clock because I had to work, so.
I had been working on it since 12 last night and got it done at 8.
Wait, 12 last night?
Or not 12 last night.
It's like,
I
12
was like,
yesterday.
whoa, hold on a minute. No, yeah, yesterday.
Where do you work?
I didn't work yesterday.
Oh,
but
you said you were working on it?
I was working on it, yes.
For 8 hours?
Yes.
Lauren?
Yeah. Cause I understood it. It's just, it was kind of time consuming.
Yeah, it was time consuming. I have like, I think I filled out like 5 pages.
I mean, I guess I did have like a lunch
I
break,
did.
but still.
Well, that's good.
It was a lot of time.
Were we supposed to be able to rip them out?
No, I'm just gonna look at them. You don't have to rip them.
Okay.
Sorry.
That's okay.
A lot of pages.
I thought it was so satisfying
Yeah, I
to
have
like do it and then get the right answer.
What?
Yeah, I think
I
that's
thought it was
exciting.
really satisfying to like
Yeah.
go through it and like get the answer. and
I
have
like
it be
that they
correct.
have the answers there.
I think that's why I like making records. Because you get like a beautiful product.
Yeah.
It's
like yes.
I have my own little business.
I'm not seeing the connection between
We were
those two
just
things.
talking
We
about
were
it.
just
Oh,
talking about that. Sorry. A little off topic.
Getting the right answer to a physics problem is the same as making a record, and I don't know, I think.
No, this is
Well, it's like
satisfaction.
Like the satisfaction of like figuring something out, or like the product of it, because that's why I love like
so
to sew stuff. No, you're fine. Wait, where? I don't see it.
It's in my drawer.
Oh. That's a good idea.
I know one.
So no one staples their finger like I did. I did that. I was stapling something in like 7th grade or 6th grade or something, and I got a staple in my finger. I was like,
Couple questions.
I think I remember
Yeah.
that. Yeah, you were here.
Very good. It's mainly to reduce clutter, because I trust all of you. But my stapler did get broken many a time when I left it out. Outside.
Well, I feel like it would be dangerous.
Oh,
just like it could be used as a weapon.
Yeah.
Just like in
trailer.
Have you ever seen like the Batman movie where he takes like the stapler and he acts like it's like a gun? No. And he like cocks it back, but it's like he's like
You can actually shoot staples out of a stapler. And
I like that
I've
staple
seen
gun.
that done. I'm like, oh,
Those
it
are
actually is on
staple
my
guns are kind of scary.
They're wicked.
Thank you.
I always get scared when I'm using one because we have one for our targets, like at the shooting range. So it's like staple.
That's so weird. I get freaked out
Okay.
because when the boys are looking at stuff.
Oh yeah.
You have a camera pointed at the TV, so I guess I should work from out.
black.
Alright, what questions do you have?
Mine were just on the last two. It was, I got into the middle of it, and I was like, okay, cause it's two parts to it, like, you're supposed to like compare between, two characters, and I think that's kind of what got me, is the whole compare and contrast, who has more distance on each other. It's not 132.
It was not here before.
No. Last period.
The internet isn't working, so maybe it could be that, I don't know.
The internet isn't working?
Yeah, like it's the connection or something, I don't know. These names were like cracking me up. I was like, what? It
Well,
was just working.
You might have to readjust the
It was just working.
It's so frustrating.
That's weird.
Technology. What if I like...
And you're so tech savvy, so.
Well, I just really feel like sometimes there's no explanation.
Yeah, it doesn't work.
It's like physics problems.
That's funny.
It was really funny, when I was going through them, I like got my answer, and then I like clicked to see the answer, and it wasn't right, and I was like, okay, like I would like, alright, there's like holes in my paper because I erased so many times, and then it ripped the paper.
But then you got the
And then I got it, and I was like, oh, okay, that makes so much sense, but why can't I do that in the beginning, and stupid little mistakes, and it's just, it was frustrating for sure.
I always make
There
stupid
was-
little mistakes.
There was like one in here where it was like, and the VI is going to be negative because it's going down, I was like, what?
Alright, what number is that? Can you
34
move
and
the
35.
camera to the board? Which one?
34 and 35.
I need to probably turn my head off and come again. Alright.
Are you gonna like take these? Or are you?
No.
No.
Are we just getting like a participation grade?
Well, you have all the answers, so
It doesn't really make
there
sense.
wouldn't be point in me checking the answers.
Right?
It's to prepare you for your
Yeah.
test. Alright, 34.
It's showing up right now.
Oh, it is?
Yeah.
Well, it did, and then you go to something, and then it go black.
Yeah, see, it goes like black.
That's when I tried to put it to my iPad. It's only...
That's weird.
Alright. Okay. 34, a tortoise and a hare having a 1,000-meter race. The tortoise runs the race at a constant speed of 2.3 centimeters per second.
I love how it's.
So we have tortoise. And that would be what? What variable should I use for that? For his constant speed.
2.3 centimeters.
Right, but we don't usually use speed.
No.
It's his rate.
What?
Like it's his rate.
Right, which we normally call what?
Yeah.
Velocity. Okay, so his velocity, which is constant, so we could say his initial and final velocity are the same. We'll see what information we need to come up with later on, but it's 2.3 centimeters per second. Okay, and then the hare moves at an average speed of 1.5 meters per second for 10 minutes, and then decides to take a nap. I might even do a graph. We'll see what's helpful. But the tortoise would just be like that, right? Okay, so then we have the hare. And his velocity is, what did we say? 1.5 seconds for 10 minutes. takes a nap. That would be 0. After waking up from the nap, the hare recognizes that the tortoise is about to cross the finish line and immediately accelerates from rest with a constant acceleration of 0.5 meters per second for the remaining distance of the race. It doesn't say how long he stops for. Then after that, his acceleration is 0.5 meters per second.
For his velocity, is it centimeters per second or meters per second?
Well, it said, oh, it did say meters per second. The tortoise is centimeters, okay. Thank you. If the tortoise wins by a hair, no pun intended, then what is the time in hours that the hare napped? Okay, so it's a 1,000-meter race. So D is 1,000. So we need to figure out, what do we need to figure out first?
The time that the hair was like napping.
Well, that's ultimately what we need to decide, right? But we're comparing that to what?
The time it took the tortoise.
Right, which is going to be the easier thing to determine, right? So let's first figure out how long did it take the tortoise to do the race, right? How are we going to do that?
Distance equals rate times time.
Yeah, you could use distance equals rate times time. That's why you said that the velocity was the rate. Or if you want to use, if you don't think of that, then, and you want to use one of the 4 formulas, you could say that his initial velocity is 2.3, his final velocity is 2.3, and then use the formula that has those 4 in it. But it will end up to be the same. So 1,000 equals 2.3. Now wait, because this is 1,000 meters. So let's change this to meters per second. What would that be?
0.0230.
Yeah, okay. So let's say 0.0230 times t. So how long does it take the tortoise?
It's a really big number.
But what units is that going to be in?
Seconds.
That's seconds, right? So what is it?
43,478.265.
Let's change it. What would make more sense? That's seconds. What should we change it into? Yeah, let's first change it to minutes. So if
Oh, well, yeah.
and then, yeah, so if we divide it and we'll see how many minutes. And then we can change it to hours. Or we can leave it in minutes, depending on what we want to do. Well, they ask for the hair in hours, don't they? So yeah, let's change it to hours. So 1,000 divided by... divided by 60, divided by 60. So it takes him, how long did you guys get?
12.
12 hours. That's a long time. Okay. So the hare, for the first 10 minutes, goes how, let's say how far does he go in the first 10 minutes?
Does he stay still?
What?
Doesn't he stay still?
No, isn't he going at a constant pace for the
Oh.
first 10 minutes?
Wrong problem. Never mind.
The hare moves at an average speed of 1.5 meters per second for 10 minutes. And then takes a nap.
So can we use t equals r times t again?
Yeah, and we're gonna have to think about the whole minutes and seconds thing. So, it'd probably be easier to convert minutes to seconds here, and then we'll have to convert it back. So 10 minutes would be how many seconds?
600.
Yeah, okay. So, for the first 10 minutes, distance equals rate times time. So we don't know what the distance is. The rate is 1.5 meters per second and the time is 600 seconds. So how far has he gone in the first 10 minutes?
900 meters.
900 meters. Okay. And altogether he has to go, I'm sorry, 1,000. So, and that only took him 10 minutes. So then we need to figure out how long it would take him to go when he's pulled back up. So he's at that point, the distance after he wakes back up is gonna be what?
100.
100. He has 100 meters left. And his acceleration, so that's 100 meters, his acceleration is 0.5 meters per second. And we're trying to find time. What's the other thing we need to use a formula?
Initial velocity.
We can use initial velocity, which is what? 0. Okay, so which formula has those four in it? So this is for after he wakes up.
We could use d equals initial velocity times t plus 1/2 times acceleration times t squared.
Okay, so 100, and are all of our units okay for this? Yeah, I think so. Okay, so 100 equals 0 times t plus 0.5 times 0.5 times t squared. So 100 equals 0.25 t squared. Divided by so t equals, and that's 20 what?
Seconds.
Seconds. So how long, if he didn't take a nap, how long would it take the hare to finish the race?
620 seconds.
Okay, 620 seconds. So the total time it takes him is 620 seconds, or that would be 10 minutes, 20 seconds, or, yeah, it's not a really good fraction of an hour. So total it takes him 10 minutes and 20 seconds. And it takes the tortoise 12 hours. So how long did the hare nap for? If you wanted to leave this in seconds, you could do the 43,478. Let's just leave it at that. 43,478 minus the 620 seconds for the hare. So he napped for 42,858 seconds, which is how long?
11.9 hours.
11.9 hours. I don't know how they give the answer in here. Oh, that's what it says. 11.9. Okay. So yeah, there's a lot that goes into that, huh? And then 35. Okay. Hayden and Matthew are riding around the neighborhood on their scooters. Hayden is at rest when Matthew passes him moving at a constant speed of 0.37 meters per second. After 1.8 seconds, Hayden decides to chase after Matthew, accelerating at 0.91 meters per second. How much time must Hayden accelerate before he is side by side with Matthew? So it's similar. So what do we know about Hayden?
His initial velocity.
Go ahead.
His initial velocity is 0.
Okay. What were you gonna say, Lauren?
His acceleration is 0.91 and we're looking for his time.
So, what do we not know?
Distance.
How much time must he accelerate? Alright, what do we know about Matthew?
His initial velocity is 0.37.
Okay, what else?
Was it his time that was 1.8?
Yeah, I think so. He was going for 1.8.
Well, it's 1.8 seconds before Hayden tries to catch up with him. Right? Is that what we're looking for? I have 2 green markers. So, Hayden, let's draw a picture. Here's Hayden, he's just sitting here by himself. And Matthew is going along. And he's just moving at a constant speed. And it's Ben, here's Matthew on his scooter. And he's going along and he's passed him, there's already been 1.8 seconds before Hayden starts to go, right? Okay. And how much time must Hayden accelerate before he's side by side with Matthew? So we need to know distance. We don't know any distances, right? So first of all, how long would it be for this 1.8 seconds? So let's say time, and his final velocity is going to be the same as his initial. So we can use distance equals rate times time, I guess, and just to call that r instead of initial velocity. So he has gone how far before Hayden decides to start? Oh, you guys got? Okay. So this is 0.666 meters before Hayden goes. So Matthew has that much of an advantage, but he's still moving at a constant pace. And Hayden is accelerating. Okay, so let's see. Let's first figure out how long it takes. So let's say the distance here is 0.666. So then we can find the time that it would take for Hayden to get to where Matthew is. Did any of you get this one? Yes? Lauren? Is this what you did? Or what did you
I
do?
did like distance equals, 1 second, I have to see, I used one of the kinetic equations, just what it is.
Okay, which one is that?
I used the distance equals initial velocity times time plus 0.5 times acceleration times t squared. But like in the video, I think he didn't use the distance, he just put like d equals and then like initial velocity, which is 0 times time, plus 0.5 times the acceleration is 0.91.
And then like set them equal to each other? Okay.
Mhm.
Alright, so I'm changing. 0.5 times, what is that, acceleration times time?
Times time squared.
Okay. And so instead of saying 1.8 seconds here, we'll just say time and then we'll say where they are equal. Is that what you did?
I did 0.5 times 0.91 in this equation right here, like the distance equals initial velocity, and I got like the time equaled 0.455, and then I set like 0.666 plus 37t equals 0.455 t squared, and then you have to do the quadratic equation.
Oh, fun, okay. Alright, so the distance is 0.455 t squared. Right?
Mm-hmm.
Okay, and then what did you do next?
I had 0.666 plus 0.37t equals 0.455 t squared.
Very good.